Math 1343, Week 8, Video 8, Test for Association between two categorical variables. So far in this series of videos, we have been introduced to the chi-squared distribution, which unlike the T and Z distribution does not have any negative values for chi-squared, since it's the square of a real number. And we've also gone through a goodness of fit test, which was testing multiple population proportions simultaneously. For example, well, I'm not going to cite examples, you can watch the previous videos. In the rest of the videos in this series, we're going to be looking at what's called a test for association, which at its core is also testing multiple proportions simultaneously. It just does it a little bit stealthier in the sense that you usually don't actually see the proportions, but I'll explain where they are when the time is right. The purpose of a test for association is to answer a question of the form, is there an association or a correlation or a relation between one categorical variable and another? For example, is there a relation among people who earn a degree in some area of legal studies? Is there an association between gender and type of degree? Now, you're probably thinking or saying, of course not. There should not be any type of relationship between your gender and what type of degree you earn. Your gender should not dictate whether or not you can earn a certain degree. Sorry, I thought my phone was ringing. So your default is probably no, that there shouldn't be an association. Whether or not you earn a bachelor's, master's, or doctorate degree in some area of legal studies should have absolutely nothing to do with your gender. And I would agree. But sometimes data will show otherwise. For example, in this data, which was obtained from the U.S. Department of Education, National Center for Education Statistics, Integrated Post-Secondary Education Data System, IPEDS for those of you in the education business, fall 2018, shows that there were 1,340 males who earned a bachelor's degree in some area of legal studies, 4,110 males who earned a master's degree, 17,383 males who earned a doctorate degree, 2,899 females who earned a bachelor's degree, 5,067 females who earned a master's degree, and 17,161 females who earned a doctorate degree. Now, some of you might be wondering, why are the doctorate numbers so much higher? Don't you have to get a bachelor's before a master's and then a doctorate? And the answer is, and some of you may not know this, to get into a law school, you don't necessarily have to have a law degree. In fact, I once read an interesting statistic that of all the people who take the LSAT, basically like the SAT for getting into law school, the type of undergraduate major that usually performed best on it were math majors. And if you're wondering why, it's because math at its core is built on logic and reasoning skills, which are critical for going into legal areas. But I digress. Based on this data, can we determine whether or not your gender has any association on whether or not you could earn a bachelor's degree, master's degree, or doctorate degree? And like I said, we would hope the answer would be no, but sometimes the data says, well, maybe there is, and if there is, we need to figure out why and do something about it. So as we go through these videos, we're going to be developing how to perform a test for association. Now the good news is a lot of the moves that we're going to do are very similar to the moves for a goodness of fit test, so those videos won't take too terribly long. But in this video, what I would like to do, besides introduce the question we're going to try to answer, is how to state the hypotheses. There's only two hypotheses here, and both of them are going to be in words. The question is there an association? So the answer is either yes or no. One is the null, one is the alternative. One of the hypotheses is there is an association, and the other one is there is not an association. Which one do you think the null hypothesis would be? Do you think the null hypothesis would be there is an association between gender and type of degree earned, or there is not an association between gender and type of degree earned? The answer might surprise you because the null hypothesis is actually there is not. There is not an association between, and in general, you would always start your null hypothesis like this and then just state the two categories that you're looking for an association between. There's not an association between gender and degree type. So if that's the null hypothesis, it shouldn't surprise you that the alternative is there is an association. So is not in the null, is in the alternative. Now these aren't your standard hypotheses, although they're perfectly acceptable. Hypotheses are claims about population parameters, claims about proportions, claims about means. This doesn't seem to mention either of those. But if you pull back the curtain and look behind at the math, as we're going to see in a moment, this is actually a statement about proportions. Because let's think about what it means for there to not be an association between gender and degree type. That would mean that the same percent of degree recipients, let me make sure I say this correctly, that the same percent of males who receive a bachelor's degree is the same as the percent of females who receive a bachelor's degree. In other words, there are some proportions implied here. What proportion of males receive a bachelor's degree? What proportion of males receive a master's? What proportion of males receive a doctorate? Or what proportion of bachelor's degree recipients are males? What proportion of bachelor's degree recipients are females? So there's actually several proportions we could ask. But if there were not an association, then you would think that the percent of males who receive bachelor's degree would be the same as the percent of females who receive bachelor's degree. In other words, those proportions would be equal if there were not an association. So it's a little stealthy, but saying there is not an association is basically saying that the proportions are the same when we compare one category to another. So they are equal, which is what we expect of the null hypothesis. If there is an association, that means your gender would influence what type of degree you could receive, meaning that the proportions would not be equal, and not equals is a symbol that you would use in the alternative hypothesis. So there's a reason why the null is this and the alternative is that. But in general, here's what you need to know about the hypotheses for a test for association. The null hypothesis will always be of the form, there is not an association between this category and that category. And the alternative will always be, there is an association between this category and that category. So now that we've kind of stated how to state the hypotheses in a test for association, all we have to do is figure out how to calculate the test statistic, and then how to do the critical value approach or the p-value approach, which we'll do both of.